Hey everybody, this is Mr. Longo, and this video is going to cover arithmetic sequences. So, a sequence in which a difference between terms is the same is what an arithmetic sequence is. And that difference is known as D, which represents the common difference. Okay? So formula-wise, A1 is the same as A. So really they're interchangeable. You can say A or you can say A1, no difference. But then we also have two different formulas. One formula is recursive. This is our recursive formula. And that relies on the previous term. So in order to write this formula as a recursive formula, you would just say A of n is equal to the previous term plus your difference. But a lot of times what we're going to be doing is trying to find the nth term. So if we were to take any nth term, it would be your initial plus the common difference times the number of terms minus 1. Okay, so that's how we're going to find the nth term. This is the function we're going to use most. Okay, so what we're going to do is we're going to find the nth term of an arithmetic sequence, and then we're going to find the requested term. So first thing we're going to do is work on given initial term of 5 and a common difference of 3. That's going to be a very easy one to do because we have both terms just given straight to us. So let's get to work. You have to remember the formula is a sub n is equal to a sub 1, or just a, our initial term, plus our common difference times the number of terms minus 1. Okay? So now let's get to work on the a sub n sequence, and then we're going to find a sub 9. So a sub n is equal to our initial term 5 plus our common difference 3 times n minus 1. And then we just have to distribute the 3. So a sub n is equal to 5 plus 3n minus 3. Combine our like terms. A sub n is equal to 3n plus 2. Okay, so now we have a formula or an equation that represents the nth term of this arithmetic sequence. So to find a sub 9, all you have to do is sub 8 or 9 into n now. So a sub 9 is equal to 3 times 9 plus 2, and 27 plus 2 is just going to give us a sub 9 is equal to 29. That's it. So that's how you work with arithmetic sequences, and using the formula to find the nth term and then using that to evaluate others. So what if we were going to find the 12th term of this arithmetic sequence? So we're still finding a sub 12. We already know a sub 1, our first term, is negative 5. But now you have to use the sequence to find the common difference. So that's a really easy thing to do. We've already done that before. So what I would like you to do is just find that D value and then try to do this entire question just like we did the last one on your own. So click pause, give it a shot. When you're ready, click play. So you should have found that the common difference is going down by 2 each time. So D is equal to a negative 2. So of course you're going to use that same a sub n equation, and you're going to have a sub n is equal to our initial or first term, which is negative 5, plus, or in this case minus 2, because our common difference is a negative 2, times n minus 1. And then you're just going to distribute that negative 2 and have a negative 2n plus 2. So we get a sub n is equal to negative 2n minus 3. So then to find the 12th term, we just substitute 12 in for n. So we have negative 2 times 12 minus 3. So we know that a sub 12 is equal to a negative 27. All right, so if you got that, you're in good shape, good to go. Let's move on to the next. Now this one's a little bit different because this time we gave you a sub 19. So now we have our difference, but we don't have our first point. That's fine. Just going to use that same equation. So we have, in this case, a sub n is equal to our first term, a, plus d times n minus 1. But we're going to first use the 19 now. So, because we have to go find a sub 1. So, for a of n, we're going to substitute in 19, which is negative 45, is equal to a plus, or in this case, minus 3 times 19 minus 1. Okay, so what we did is we substituted a sub 19, or the 19th term, is equal to a negative 45. We did that so we can use it to find the first term. So now we're just going to distribute, or actually just multiply. So 18 times a negative 3 is going to give us a negative 54. So we have negative 45 is equal to a minus 54. So a is equal to 9 after we add 54 to both sides. So now we have our first term. So now we can go back and use that to find our equation for a sub n. So a sub n is equal to 9, our first term, and then minus our common difference of 3 times n minus 1. Distribute the negative 3, so that's equal to 9 minus 3n plus 3. So that means our a sub n is equal to a negative 3n plus 12. So we now have our formula. So to find our second term, a sub 2, that means a sub 2 is equal to a negative 3 times 2 plus 12, which means a sub 2 is equal to 6. So the last question is going to be the trickiest one, because we are given a sub 6 and a sub 21. So we were not given the first term, and we were also not given the common difference. So there's a couple of different ways you can do this question. One way will kind of help you find both at the same time. And to do that, you would just set up a system of equations and then go solve. So what I mean by that is you would use a sub 6 is equal to 10 to come up with 10 is equal to a plus d times 6 minus 1. And then you would use a sub 21, which is equal to 55, is equal to a plus d times 21 minus 1. So then you would have a plus 5d, and a plus 20d is obviously equal to 10 and 55, and you can use elimination and then substitute back in to find both. But there's another way that you can do this. The other way is pretty much like a slope formula. It's just your rate of change, which in this case is our common difference, d. And that's the way I would prefer to do it. But you can do it using a system if you want. But I'm going to do it the easier way, which is, like I said, rate of change. So to do that, it's just like slope. So this is like 6 comma 10. This is 21 comma 55. To find our rate of change, the distance from 10 to 55, we're just going to find by 55 minus 10 over, and then we just have to subtract how many terms. The 21st term from the 6th term would be 21 minus 6. And that would end up giving us 45 over 15, which is a common difference of 3. So that's the way I'm going to do it. You can do it any way you want. But now that I've got the common difference of 3, I can just go substitute it into one of my formulas to find the first term. So I know that a sub 6 is equal to 10. So 10 is equal to our first term plus 3 for our common difference. And then that would just be 6 minus 1, which is 5, or 3 times 5 is 15. And then we have subtract 15 from both sides. So our first term is a negative 5. Now again, you could have done all of that using the system if you wanted to. So it really doesn't matter. You choose which one you want to do for yourself and just roll with it. So now that I know what the first term and the common difference are, we can just go use the formula to finish up this problem. So a sub n is equal to a negative 5 plus 3 times n minus 1. Distribute your 3, combine like terms, and we know that a sub n is equal to 3n minus 8. Okay, so that is the formula to find the nth term. But instead of using it to go find another term like a sub 14 or a sub 3, I want you to write this as a recursive formula. So back at the beginning, we also said that a sub n is equal to the previous term plus our common difference. So we know that the common difference is 3. So to write this as a recursive formula, our recursive formula would be a sub n is equal to the term right before it plus our common difference of 3. Okay, so that right there is our recursive formula. And it's important to know how to write recursive formulas for different things because we will rely on them from time to time when we are in the sequences and series unit. So that's just a nice little refresher for you. But anyway, that's arithmetic sequences for you, and this is Longo, and I'm out. See you, bye.